right, so this is where we stopped. So what you should be able to do on this one here is, and I've already downloaded this. I rebuilt this morning in about 5 minutes. And the only reason is because I've been doing this for 30, 40 years. So it's pretty but when you open the door, you're going to see that the open light is flashing. And if I stop, you won't see it at all. And now the ajar light's flashing. But when we're in motion, the jar light should be steady. That was the last thing we did. We did the latching circuit where we lock it in until the limit switches are tripped. Right? Everybody remember any of this stuff?
Oh, yeah.
Oh,
Okay.
yeah.
All right, good. The next step is when we're closing, they want to hit, and watch what's going to happen. I'm going to hit open. When you hit the open, if it's closing, it should stop. Come on. But I'm locked out. You see that? It's not letting me do anything. Everybody see that?
Yep.
Okay. Because we've interlocked them. You can't do anything because I've interlocked them here, which is still the way you want to go. You don't want to do it any other way. I'm going to go out of the run mode here and get back to programming. The next step is for you guys to go ahead and when this is opening or when it's closing, it doesn't matter which direction. If it's opening, when you hit the close button once, the thing stops and does not move forward again. Then when you hit close a second time, it starts to close. Or if you hit open, it'll open. So the first signal is opposite of what you're doing. So if you're opening, you hit the close, the door should stop. Then you can either open or close from there. Or if you're closing, you hit open, the door should stop, and then doesn't matter which direction you want to go. All that does is that stops the door from going in the other direction, stops it so you can go in another direction if you want. How would you think you would do this? Tell somebody give me an idea of how to do this.
It's going to be our opposite. Instead of examine if closed, you're going to use an examine if open. Kind of opposite logic. Is that what we're?
Somewhat, but what are we going to do? What are we going to do to? Let's just say I'm opening.
Okay.
I hit the close button. How would I put that in the program?
Let's go play with it.
No. I want you to tell me what your first thoughts are. Come on, Tim, you're the expert. Let's go, man.
You're the expert. All right. So I'm sorry, I'm looking at my program. I haven't looked at it. All right. So our ladder.
All right. So wait a minute. You okay, each one of those got a rung, the open rung and the close rung, right?
That's right. So what you got here is if you're looking at this one here,
We did
and I hit the open, I'm moving up. I want to stop this and just be dead stop. And then I can either go up or down from there. So what would I do to make that happen?
So when when LS1 is closed, it should.
We're in motion now. We're in motion. We're between the two coming up. And I want to say I'm opening. I want to hit closed and I want to stop it. And then when I hit close the second time, it'll start to close.
Okay, well, shouldn't you hit the stop button?
No, you got to hit the close button. That's what it tells you. Hang on a second. I'll pull up the actual thing over here. Just a second. I have it.
Basically, we're adding in when you hit close, it acts like a stop, and then when you hit it again, it goes that
right
direction.
Here. Can you see on the screen the exercise 4?
Yeah.
Yep.
No.
It says if the door is currently opening, pressing the close switch will immediately halt movement. The door will remain halted when the switch is released. If the door is closing, and when you hit the open switch, it'll halt and be sitting idle. Once the movement is halted, all push buttons have been released. The door can go in either direction if you want to hit open or close. I am not using OLT and OTL or OTU, which is output latch and unlatch. Normally in the real world, we would have to use some sort of a latching relay, which means when it gets a pulse, it flips in one direction, stays there till it gets another signal, then it flips the other way. So what we're doing is we're not going to use those. I want to do this strictly on the bit logic without the OT setup. This is not going to be as simple as it looks, but you know, you have the information to do this. We just have to figure out how to do it. So it says utilization of, what is that word?
Are you showing that on the screen? What's
Yeah, are
wrong?
you sharing that?
You see
Right
it?
now,
You see it?
right now what you're sharing, Sam, is
Okay, it's not letting me do that. That's the problem with this. I can't share my desktop. I can only share a piece. So let me stop sharing here. And I will share that and see if I can figure it out here. Let me try this.
Okay.
all right now.
So right
Now
here,
it
it
says-
says here, utilization of binary or integer table bits to flag a condition. That's how I want you to do this program. This is what I tell my students. I do not allow them to use OTs in this one. I use those somewhere else, but because they're very complicated to use in bit logic and can get you very, very messed up if you're not careful with them. So we're going to utilize the binary bits B3s. We're going to flag conditions because I'm going to show you what's going to happen here if you don't do it. Let's just assume that I'm going to put something in here to stop this line. What would I use to stop this line in here? Well, if I'm going closed, right, open, and I want to stop this, I would put the closed bit in here, right? Does that make sense?
Okay,
I mean, I'm going to put it as not as open so I can run this until I'm ready to hit the close button, right? Same on the one down here. I would want to try this and put the open button down here. It's open PB down here. And I'm thinking when I go through this, it's going to stop it. I allow students will do this all the time. And it's not going to work right. I'm going to show you. I'm going to open. Speed it up just a hair. Now I hit the closed. What happened?
it
What happened when I
reversed.
hit closed? It just reversed it. It didn't stop and halt like it said.
Oh,
Because when I hit close here, I'm also hitting closed here. When I hit close, since it knocked this out, this line is now active and it immediately jumps going down the other way. So you cannot use these two bits to do this. You have to flag the conditions. That's what your binaries are for. They're outputs so you can run internal relays. Oh, come on. Or you can set up a flag condition to flag something. So what I'm going to do is, and it's been a while since I've done this one, but come on. But what I'm going to do is I'm going to flip over and I'm going to say, if I am moving in the up position, which is this one, right? Everybody got it? And I hit the close button. Where's my close? I'm going to trigger a bit. And if I open my data table up here, that's what remember the little tools are your data tables. And I will go to the binary. I'll just grab the very first bit. They can be outputs and inputs. So this is now a flag condition where I'm saying I'm moving up and I want to close and go down. So what I'm going to do is I'm going to latch that on. And I don't generally, I don't put a lot of stuff on the information on this, but just so you guys know, this would be like flag up. I'm moving up. And I don't normally do it this way. What I usually do is which we're going to do next here in a few minutes, is I run comments, which is what I'm going to show you I do with my students in the next little exercise we're going to do before we get out of here. And this is flagging that I am moving up when I am wrong one. Damn it. All right, let me get this one up here. Right here. It's supposed to be moving up and I hit the close button. I've locked this bit on. Okay. Now what I can do is I can bring this bit right here and log it in right over here. And say if that bit is not on, I'm continuing to move. But if it comes on, I'm going to halt this puppy. Everybody see that?
Is that the first bit we put in here? We didn't do that last time, did we? Did we use flag data yet last time?
We did in something else.
We blinked to
Actually,
see.
remember we did a control relay, and instead of wiring a control relay, we just made a B3 to do that with.
Yeah, that was, yes. Where was that? Where is that?
That was back when the last class, the first class we were in. Very first class we were in. We didn't use it this last lecture thing we did online. And in the class, we did that. What the B3s are, they're internal relays, so you don't have to go out and wire another relay.
Yes. So if you ask the question now, what we need to do, Sam, is we need to get a bit that becomes a flag so that we can flag that condition, because we really don't want to flag the actual input device, but we want to flag what that device does for the condition.
And because you're using the closed button to try to do that, you've created a loop.
Okay.
That you're right back to closed position, right?
Yeah. Okay. So yeah. Okay.
See that? Okay.
Yeah.
All right. So I'm going to download this just to show you how this is going to work. We're just going to go open. I hit close once and it jumped right back down, right? Why did it jump back down?
Because you hadn't flagged it.
I haven't flagged this part, right?
Right.
So I've got to do this one as well. Got to flag this condition here as well. In order for this to work, that flag has to be partly in here as well. You see that? Otherwise, I'm going to be running both. I can put it here. I could put it down here. I mean, when I hit close, I don't want it to go. I can do it here so it blocks it. But even if I hit close, it's going to start to jump down. I don't want this to come on at all. So I can put it in here. I could put it somewhere else, but this is the point where I usually put them if I'm going to do them. Now let me download that and let's try it again. Oh, I got the flag on. Sorry, hang on. I got to get in there and clear the flag. I didn't clear the flag when I was in there earlier. So let me drop down here. You can see it. All right. Now I'm back to normal. Let me open.
What did you just do? What do you mean by clear the flag? What just?
I just made when I locked it in a minute ago.
Yeah.
This is still locked in. I have not reset this yet.
Okay, got it.
Yeah. So what I did is I just got this triggered going in, and now you notice that when I hit close, it stopped.
Yeah.
The opening. Everybody see that? Kind of hard to see because this thing is really hard to see through. But what I did was I flagged that condition. How I flagged that condition was I said, if the motor's going up and I hit the close button, I'm locking this flag in. Knowing that I'm going up, I'm going to stop the upside. And how I did that was I blocked it here. But I don't want to go back closed again, so I got to block it here as well, right?
Now you were saying that could go anywhere. So that could, just because that's going to read that, it's not going to matter because it's not going to have happened. Okay. So you could put it at the, as the last input, right? And it still work.
Probably. I do it inside here.
Why?
Simpler reason I do it inside here is I don't want the close button having anything to do. So it's all about the close button.
Gotcha. So I got it.
Just for simplicity
Got
for
it.
the students, I kind of do it there. But yeah, you could put it next to the stop or out between the LS2.
Yours is better. Yours is
whatever.
logic. Yours
Yeah.
is using logic. They're together. So that's good. Same thing.
Right. So I know that that's going to happen. I got it. Now the issue is I got to go the other direction. How the heck am I going to get that unblocked?
You got to flag
Right.
another condition.
Yeah, you could force it, but
Well, no, remember, I got to hit closed again in order to move it down, right?
yeah,
So I can create a second flag condition.
Yeah.
When we're talking about flag conditions, we're flagging a situation in the process. We were motioning up, right?
Yep.
And what we did was we said, I want to flag that I'm moving up, and I hit that closed, and then I blocked everything from happening with that flag. So what's my new condition now?
Want to move down.
Okay.
And so you got to
When
find
this
some-
is on, right? When I am in this flag condition, right? That means my flag up is on.
Yep.
And I hit close again. Now you got to be careful with this because you're going to have to do some real manipulation. This may not work because now I'm going to clear it immediately when I hit close. So the first time I hit close, it's going to lock it down. But if I'm in this condition and I'm still pressing that close, it's going to flip on you, right? So can I really do it that way?
yeah, you could do it that way, but I don't think it's dependable.
Why?
Well, I was thinking about the way this program is being processed. It depends on it stepping through. So therefore, depending on where the program is processing, I think could make it confusing.
It is confusing. This is a hard one concept for students to pick up.
Yeah, me too.
Exactly.
That's why I like the simulation software. It gives you these scenarios. One of the key things about this particular program you want the students to get out is interlocking with the motors, right? And learning how to use the flags. He says flags. That's the key behind this program.
All right.
So what do you think I could do now?
All right, so we're stopped or conditioned, but we want to move down.
Right. How do I know I'm stopped?
Because our right there, yeah, our flag.
No. How do I know I'm not moving?
Because our close, let me think about this. Obviously our close is active, so
I'm circling.
okay, so our output, whatever our 200200 is not active. Wait. Is that? I don't know.
You're telling me neither motor is moving up or down. It's
Yeah.
stationary. Okay.
Yeah,
That's
neither.
what I'm trying to drive toward.
Okay.
This is my other condition. The first one I was in motion. I hit close. Guess what happened?
Got it.
All right. Now I'm moving this way, right?
Yeah.
And I hit close and I don't have anything going on. What can I do? I can put another bid on, right? Flag that condition. Oh, where in the heck am I here? Okay. All of this happening. And I don't really necessarily need this inside a loop, but this one could be in the loop. Right? Now I can break this one once that one's done. Oops. Somebody else coming in, or did somebody get knocked out?
Certainly
Might be-
coming back in.
Oh, okay. Poor thing. She's having trouble, isn't she?
Oh, be quiet.
I came to campus
Hey,
because
I am
my
too.
internet at the house is terrible.
What I'm trying to do is put you on one computer so that I can follow on my own software while I can listen to you over here. I'm trying to put you over there and move
Oh, I
myself.
got it. I got it. I got it. Yeah, that
I don't
makes
know if
sense.
that's gonna work.
Well, wait a minute. You can run them. You can run them both at once. That's what I'm doing. Start the other one and use an alternate tab to go between the windows.
Yeah,
You know,
Alt tab
just-
will do that for you. That is true, but she wants to see it live while she's programming it. That's what it is. Yeah.
Okay.
Yes, and our screen
Yeah.
is small.
Yeah, that's a double monitor. She's still double monitor. That's my problem is looking at.
Right. Right. So I flagged this condition. I don't know if this will work or not yet, but we could play with this. What I can do is I can break this one so I can go down now, right? You think it'll work, or do we need to do something else?
let's try it.
All right, we're gonna try it. I like Sam's method here. That's what I try to get my students to do. Just try it.
Yep.
Play with it, work with it. It's how you learn. Okay. This is just the closed portion here, okay?
Right now, you chose another bit, right? The other one was 0 bit.
B3-1. I flagged the
Okay,
new
yeah,
condition.
yeah, good. I see it. It is different.
Yeah. It's probably not going to work because there's a couple more things we got to do, but I'm going to download and get rid of this. Now I'm going to go ahead and open again. Oh, I got to clear that bit. Sorry. I hit close. It should clear it. I think if I did it right. Yep. It's closed. Everything is off. I should be good. Okay. Let me put it in run then. Okay. Let's open. Oh, is the bit still locked on? It sure is. Let me clear the bit. Sorry about that. Keep forgetting. I should have a clear bit symbol in there, but I didn't do it. The last when you get off, whatever was on there last is going to be downloaded with these bits. So sometimes I'll put a push button in there to clear bits just so they do it. And we can show you how to do that later. But right now I'm going to open. It closed. What happened?
Went straight to close.
Right, because it looped, right?
Okay.
Interesting, huh?
Yeah.
So when I close and I'm holding this button down, I am now what? In this mode, right? But I'm also holding the button down here.
Okay.
So what if I hit this close? This is going to be maintained. Immediately clear it, right? Does that make sense to anybody?
No.
Okay,
No, not too
I
much.
push, I lock this on, right?
Okay.
If I come over here, get offline here, and I release that button, what happens?
it's gonna stop.
Well, it's not going to go if I release the close button, right?
Right.
And I'm going to reset it. And now I can close.
Okay.
That make any sense to anybody?
Yeah, a little bit.
All right, let's try it and see if it works. There's more to this, but I'm just saying, you know, that's what we're, so let's open. Close. Now I'm going to hit close. Everybody see that? Everybody understand what happened there?
You can do that, and let me see. I was watching.
Watch
Yeah,
here.
close.
Right, it stopped, and then when I hit close, it closed, right? Because when I push the button in, I'm locking this on, which is going to block up there, right?
Okay.
Y'all saw that, right?
Yep.
When I release the close, guess what's going to happen?
Okay, bit 3. So we're going to.
And that's going to stop this. So the second time I hit the close, guess what's going to happen? Watch one more time. I hit close, I hit this, which stopped up there. When I released it, this came on and cleared this bit. Now, if I hit close the second time, I'm ready to go again if I want to. I set up 2 flag conditions. Flag 1 is if I'm moving and I hit the other button, I'm flagging it. That I'm going to, and that's going to block what? Whatever direction I'm going. So it's not necessarily flag up. I just put flag up so you can see where we're going. The second one is a reset the flag. So I don't need any more bits because what I can do is, depending on which condition I'm in, moving up or moving down, I can use these 2 to do everything. All I did was I closed, this became active, this came on. The minute I release this and everything is stopped, this went on and cleared it so I could go down. This is the difficulty of logic and logic gates. This is where students get bogged down right here.
Yeah, totally agree.
So before I ever got here, I went through the logic tables, the logic functions, what is not, and, in and, exclusive or, all that stuff, right?
Right.
They're heavily beat up in that. When they come here, they still can't see it. All it is I'm stringing logic in front of this output to cut it on. I'm stringing logic in front of this output to cut it on. This stops my unit up there from running. When I release, I clear it with this bit. So as long as I'm holding that, this will stay on. Let me open one more time. I'm holding the bit. Notice that the first flag is still on. I'm holding that closed button. The minute I release that closed button, I've reset that one, so now I can go closed. Very difficult concept. If any of your students figure this out on their own, and I've had many, they are going to be good programmers. They're going to know what they're doing. The other ones just need a little more work with how to string the logic. And all I'm doing is I'm flagging a condition, okay? And the reason I don't like to use the OT ones is because they need to understand how to use the B3s, not only as a, and this is a relay. If I did this relay logic, the B3s would be relays. So I'm not using them because I have 8200 relays in my PLC, virtual relays. I don't need to wire anything. I could do this with programming. And this is how I'm stringing my logic together to abandon the other. So now the other one, all I have to do to get the other one to work is copy it on this. So all I'm going to do is I'm going to come down here, bring it here, move this under here, put two more of those on here. This time, instead of being closed, I'm going to be motor down, and I'm going to be the open PB. It'll still work the same way, and I have to go up top here like I did with the other one. See how I flag the condition here? I got to put the same flag here, and I got to put the same flag here. And that will solve the problem for you. Except I'm going to change the name of it. I'm just going to call it flag motion or whatever. Or you call it motion flag, whatever you want to do. And then this one I would just call reset. That way I can reset that motion. So reset motion flag. Let's try it. Let's play with it a little bit. All right, I'm going to open. Things not move as fast as I like. I think my computer's it closed. It closed. Now I'm going to hit open. What happened? What did I not do?
All right, do it again.
Now I didn't reset it because I failed to put my open button down here. This is the two hardest things in this whole project. But it's critical that your students understand how bit logic works. This is a very important on flagging conditions. These two lines control that door pretty heavily. All it's controlling is, am I in motion or am I not in motion? Think about it. If I'm running and I hit one or the other, I'm locking this flag on. As long as I'm holding that button down, it's locked on. The minute I release, now I'm ready to go back the other way. I clear this, so the second time I hit it, it will allow me to move in the correct direction. Very difficult concepts to understand. Believe me, when I first started programming, of course, you know, I was on the old handheld teach pendant thing where you only get to see one line at a time. You had to write all your programs out. What a nightmare that was. Then when they moved to the DOS, I thought I was king of the world because in the DOS version, I could, you know, see more rungs. And then now they got into Windows, it's really good. What questions can I answer for you on this? Because this is a key concept here.
I just got to go play with it. This isn't something I can just watch somebody. I've got to retrain my, you know, so I can't, I don't have a right question to ask. I follow what you did. I couldn't replicate it.
All right. So what I want you to do, you have a folder somewhere. I don't know if you're using a OneDrive or wherever you store all your stuff for your classes. So if you got access to your class folder, like on a computer somewhere, you can get to it. save this as your class number, and this is your, put a folder in there that's Logix Pro Solutions, and this is your solution to it. There are other ways to do this. I'm going to tell you, this is just one concept on how to do this. It's probably the easiest concept, but this is one way to do this. Okay. There are other ways. And as we move forward in December, you're going to see simpler, faster things you can do. But for right now, this is flagging a condition to do something. I'm flagging a condition to stop the door and go in any direction I want to go after that. Motor's moving up. I press the close. It locks this on, right?
Mm-hmm. Yep.
So the door stops. I release this. Guess what? This comes on and I reset this. I hit close again or open, doesn't matter. It's going to run. It's just going to take off up there and run because this is not on. Now I'm closing. I hit the open. So I'm moving down and I hit the open button. As long as I hold that open button, it locks. When I release it, kills it. So when I hit open again, it's going to go up instead of down. This is how you have to think in your logic. I think I had an instructor in Georgia that worked for me, and his saying was, when you learn how to think like a PLC, you can program a PLC. And that's all it is. You have to think logically. You have to put your logic in order to work.
But it has to be nested this way?
I'm sorry?
Does it have to be nested this way, the way you have it here?
There's some other ways you could do it, but this is probably the simplest flag condition I can give you. What some people will do is they will flag going up, they will flag going down. They'll have a reset for one, have a reset for the other. I just combined it a little bit to make it a little smoother. But you're going to see, I'm going to tell you, there's probably 5 or 6 of us in this classroom. And if I gave you any kind of a project to program, we'll have 5 or 6 different ways of doing it, and they all work. I really beat my students up on, do not go in there, look at a program and say it's wrong. If it was running and running good until something happened, that program is good.
All right.
Now you go in there and make sure that you're getting your signals in, out, all that stuff. Because 9 times out of 10, it's going to be a problem on the floor, not on your program, unless somebody went in and made a major change in there and didn't do it right. But it wouldn't have been running to begin with. So if it's running and suddenly stops, you go into the program not to modify the program, but to troubleshoot. And 9 times out of 10, you can do it with the lights. If you have the program, you know what the program does. You can just look at the lights and tell. But I like going into the program because I see there's a valve on and the valve is closed. It's not coming open like it should be. That's a problem with the valve. I'm getting a signal from the PLC. So if I'm at home and I saw that and I called the tech is there on the floor, I said, see if you're getting a signal to the valve. And so if it does, he goes, yeah, I am. I'm getting the voltage to the valve. It says, with my output saying it's on, so it's not in the PLC program. It's got to be that valve. It's either stuck or it's not working anymore. And then they'll take it from there. I'm done. I go back to bed, 2 in the morning, whatever.
Okay, Sam, do me a favor. Do me a favor.
Yeah.
Go through rungs 5 and 6 from left to right again.
Okay, so I'm coming in. The motor is in operation going up, right?
Right.
I push this button. The minute I push this button, this comes on, right? This bit is locked on.
1B309, okay.
Do you see that?
Yes.
Yep.
Right here, it's going to stop that motion.
Okay.
See it right up over here?
Yep.
The minute I release that, what comes on?
Okay.
And that's what's going to reset this. If this is on, this cannot be on.
Okay.
So now I'm ready to go in either direction because I'm back to this situation where this is no longer blocking anything. But I'm not pushing it to engage it, right?
Right.
Okay.
Now I push it the second time. This will go off, but it has no impact. The only thing this impacts is this. Because now these are back on. So if I push open or close, it's going to go in either direction because this is no longer engaged here or here.
Okay.
I don't know if I necessarily need this here. I mean, I can take this out technically. It should work the same way, right? I do this sometimes because I'll do it here so they can't push the button, but I need to stop the line. So I don't really care about this one too much. Let me download it and show you that it still probably will work without it.
Okay.
So that was just kind of obsolete. I threw it in there just to show you that I'm trying to block the signal, but this is what's blocking you from moving right here.
Got it.
Yeah. And so all I'm doing is I'm flagging condition. I am moving down and I hit the open button and that's going to stop. Because if I just use the open button up there without any flags or anything, and this is not here, the minute I'm closing and I hit open, it's going to immediately go jump up. It's not going to allow us to stop it. It's just going to go down and start moving right back up. I don't get that stop motion. So I have to flag that condition to stop it. It takes students a while to get through this one. And the last one is the only one I as I said earlier, before you guys, the rest of you guys go on, me and Sam were talking. I told him, Sam, I only asked for exercise 4. I don't have time to grade each individual one. And the reason I don't ask for the others, well, what if they're doing something wrong? If they can't get it, they're going to come to me on exercise 1, 2, or 3 and say, hey, I can't figure this out. Then I'll sit down with each one of them and work with them. But most of them, the very basic ones, the first 3 are pretty basic and they should be able to get it to work. And in my lecture, they say, hey, I wasn't able to get this. Then I'll go over it in a lecture and show them how to move up, you know, and lock it on, interlock it, whatever. The flag, I make them play with it until they just get so frustrated they can't figure it out. And then I say, okay, I'm going to go over that. It's due, you know, today, and none of you've turned it in because you can't figure this out. So let's talk about this. I'll get them started on it before the end of the class. They'll have it done. I don't do it for them. They have to do it. Once they see it, they got it. So what Logix Pro does for you, and this is the only thing it's good for, is teaching you these program tricks and techniques.
Yeah.
That's why I love it so much. This is so powerful. So everything moving forward from this point, they'll understand I can flag a condition. I can reset the flag. I can do a lot more stuff now because I've got these bits that are going to help me out. Everybody understand that?
Oh, yeah.
Yeah. That's the whole purpose behind this.
Yeah. This is powerful.
Yes, it's going to work the same way in 5000, except you don't have B3s. You create your own internal bits. So you got an infinite amount there. But I mean, that's the whole purpose. Now I've seen some of them and they get a little ridiculous. Okay. They got 20 of these things down here trying to get that thing to work and they finally figure it out. And then I show them mine. They go like, what? Well, it's okay. Yours is just as good as mine. As long as it works, that's all anybody's doing. What I'm going to show you next is the next exercise. So I want you to save this as door solution and save it somewhere where you can get it in case you decide to use the software with your students, that they will learn how to do this kind of stuff and you'll have the solution there. So you will remember how to do it later. And then what you need to do, like Tim is saying, I just got to sit down and do this keep this, but then go in and try to redo this on your own and see if you can figure it out. Be a student for a change. Work from a student perspective. That's what you're doing now. And try to rebuild these. And every 6 months, I come back and rebuild them and see if you can remember how to do all this stuff. Because when you do that and you do it multiple times, you're going to be pretty expert at it.
Yeah, this is invaluable.
Yeah, I think that's why I love these things here. This teaches you so much. It's incredible.
Plus the visual graphic, because I was using just downloading the RS, trying to learn it with just the emulator, and it's all right, but this is wonderful. You see it because it puts, especially from the student perspective.
Yeah, I don't promote vendor equipment or anything else, but there is one more piece of the puzzle that I use that some people will get, some don't. It's expensive. It's called the EasyV. It's that one word. If you go easyv.com, they got free simulation for the students with their free software on a Micrologics. The only thing they can't get is the module. The module will connect to any process and connect to any PLC. If you connect it to your computer, the simulation that you download, EasyV, will work with your PLC. It's live. This is not graphics like this. The graphics are good, but it does a whole list of other things using some of these same techniques. I make them do both, plus I give them extra labs to do. I am going to tell you this, and I'm not going to be expecting anybody to follow what I do, but what I found out years ago was the more they do this and practice and repeats, like playing a piano, guitar, whatever, the better they are going to be at this. They're probably over 2 full semesters. They are running between 60 to 100 programs they've written before they leave the thing. And that's maybe over 2 or 3 semesters. Okay. Not all at one time. You don't have time to grade that many. So they may do 20, 30 one semester, 20, 30 the next. And if you do another course with the programming, like my automated process, I have a process station that we hand built, and they have to go through the PID loop on a 500. And that's how we're controlling the process using PID. That is what they have to do. And that's a whole nother scenario. So those are the kind of things, and that's advanced stuff. That's very advanced stuff. But
Okay,
I'm teaching
what's the
them
name of that software?
Huh?
What's the name of the software? EasyV?
Yeah, it's all one word, easyv.com, VEEP, like, it's easy and then VEEP.com.
Okay.
And the software's free. You can download it, but it's hard to get going on your system. The issue you're going to have is if you're not fully updated on your Windows, especially if you're on 11, well, 10's the worst, but 11's a little better, but you need to make sure you got all your cumulative updates on, and then there's going to be some optional updates in your update. When you hit optional, you'll look down and there'll be EasyV. It will connect up once you do. And there is some USB software that you can buy too, but it works off of a standard printer cable USB. You plug that into the module and then you plug it into the computer, and then the PLC is wired to the module. And if any of you want to come by in December, I will sit down and show you how it works. I'm talking to my TA, Chris, who's also an adjunct. I'm asking him to help me set up 5 or 6 stations with him so you guys can see how it works. So you guys can play a little bit with it.
Okay.
Then, yeah, that'll be nice because we're going to do some things on there. And that has some really cool software stuff on it. And you'll be using your laptop with the Microsoft Light on it to do them. So it won't be that bad. And then I'm going to have you guys some 5,000 level PLCs here. So if you don't have the software for the 5,000, I have computers here, laptops with 5,000 on it. So any more questions about this particular one?
So like you said, you give them come back with your exercise 4. How far where are you at the end of this exercise 4, the first time they're working with PLCs?
We're about a little over halfway through the course. The first half part of the course.
So about
I don't
now.
start. Huh?
About right now? If you're
No,
in-
no, a little sooner than that.
A little sooner, okay.
Next one, the next two I'm going to show you. Well, we're about to get into timers and counters, so we're moving to the traffic light one. The one in between this one, which would have been done this last week or so. So it's about about a week and a half or 2 weeks ago, this would have been due.
Okay.
Because what I'm doing is I'm getting them to do some really simple things. Turn a light on.
Yeah.
Turn a light off. Latch a light on using the OTs. Unlatch that light. You know, that kind of stuff. I'm doing some really basic programming. Let's start, stop a motor, and then cut a light on when the motor's running, and then cut a light off when go red when the motor's running, and green. I'm doing all kinds of stuff like that through a PLC, and they're gonna get freaked out because they've been in the motor controls wiring all these hairy start, stop, taking them 30, 40 minutes to wire one, and they can program it in a matter of minutes and wire it up. And they're going like, that's when they start throwing rocks at me. Why didn't you show me this before? Blah, 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 I told them that's going to happen, but we have to know how it gets there, how we got here. So that's how you're doing it. So this is about week 6, 7, somewhere around there. Maybe I have to go back and look at my course, but
Do you have you have a prerequisite for your PLC one then?
no, I have a co-requisite. They have to have taken or be taking motor controls with PLC. I prefer they do both because here's the reason why. They're young. They have not been exposed to relay ladder logic.
No.
And if I get an old man in here like me who's grew up with relay ladder logic, it's near impossible to get them over to PLC ladder logic. They're thinking these symbols are normally open, normally closed, and that shouldn't be working like that. I should have a normally open, examine if open as my stop.
Yeah.
No, that's not true. And I had one guy who worked for General Motors say, that's how we program those. I said, I guarantee you it is not. That's illegal. OSHA found out they're gonna shut that plant down. And he's going, you no way. I said, go look at the program. I want you to have one of your techs open it up and show you how you did it. It took me almost 2 semesters to get that guy to realize I was right. He just could not get it because he's old school relay. And that's why
that was my frustration I just think backwards now from, it's literally when you're looking at the contactor.
For guys like me and you, and probably Sam, I imagine he's the same way.
Yeah, I am.
Because we're all relay guys. We grew up with relay. PLC came on board while we were working. The problem is we have to go opposite. Just think it's opposite of what relay is.
Exactly.
So look at these symbols as in the normal condition.
Yeah.
What condition is the examine in closed here? That's in the normally open position. All this is saying it's open and I'm waiting for it to close.
Right. Examine.
Right.
Examine.
Right.
I drive home the examiner. Right. Examining.
Yeah. But I still have people like Automation Direct calls it, normally open contact. I'm saying that's not right. Nobody else does. Yeah, I said, you guys are way off base here, and because they're old school relay guys,
Totally agree. I had to change. I finally switched to the right vocabulary. That was my frustration that time. Is exactly that. I finally got my brain to go, okay, learn this logic. This is logic.
Yeah. Well, I catch myself periodically saying the same thing. Yeah.
Say that one more time.
Something else that's confusing about this is I use Amatrol's equipment to teach this course, and Amatrol has the EC90, which has a PLC on it. They also have the same portable unit without the PLC. Okay, the one without the PLC, you teach it purely from the relay standpoint.
Yes.
Then
yes.
you got to go and take the same board and teach it from the PLC standpoint. And yeah, I see yours over there in the corner, right? Right. You got to teach it from the PLC standpoint. So now you got to get them looking at the relay logic and saying, like that open relay right there, that's an XIC.
Exactly.
So if XIC, give me a 1 here.
Right. Yeah. So what I do is I have the 990 EC1 portable.
Okay.
strictly relay logic. And what I do is I have some of those, I bought extra banana clips and cut one end off to tie into a PLC, and I make them run it through the PLC.
Oh, okay.
And
Yeah,
then
was thinking of doing that.
I said, now program this with the PLC.
Right. See, that's what I'm
And then they
thinking
have
of
to go
doing.
back and see the difference.
Right. That's what I'm thinking of doing, is let them set it up on those 990s and then get a PLC with leads and banana clips, like you're saying, and plug
Mhm.
into it to test those switches and run it
Absolutely.
from a PLC standpoint.
And if you
Okay, I
have a
got you.
board, if you have a board like I do, these panels I got in here I bought them from Granger now. You can get them from Granger. I make them wire the motor control circuits up, but then I make them go back and wire the PLC into the drive or into the motor starter. And I make them wire the overload back to the PLC, and they have to set that program up. And they have to
Okay.
build it and make it work just like as if they had wired it using relay ladder. My second level PLC, there's no wiring of anything except the outputs. My inputs now are from the HMI. So in this one here, it's all internal between the HMI. So my inputs are all B3s or B10s.
What do you have that has an HMI on?
That's second level PLC. It's the one with mine's called industrial applications using PLCs and robots, because they have to program
Yeah,
robots.
that's 1540. I teach that too.
Yeah, that's where I put in my HMI. First week we go over Ethernet IP and how that works, and they have to make a cable. And then I make them do we start working off of how to build an HMI screen, because I'm going to tell you, knowing how to program an HMI and how to build one is two different things. Remember, when I tell my students, you got this one guy who is ADA. He can't see anything on a white screen because he can't distinguish. It's so bright that they can't see the letters. It's fuzzy to them. So make it yellow. It's like putting a yellow sheet over a page. The black letters still look black, but the sheets, it knocks down that whiteness on the sheet, and the operator can now see it. And so I make them change their backgrounds off white to something that you can see. I'm not a interior decorator, but I told them there are some good color code options. I give them to them from somewhere, because I have no business being in matching colors or anything, but I'm not an interior decorator. But I see some really incredible screens come from those students. Some of them are pretty creative.
I can
And
imagine.
what you can do is take a bitmap, just take a picture of the panel they've been working on. If you switch from a panel to an HMI, all you got to do is take a picture of the panel, convert it to a bitmap, and it'll go into the background. And then you send your buttons to the back of that, and there's that broken button they were playing with on the screen. And because an operator does not know why he touches a button to do anything. He just has a pattern of things he does. So if you change that completely around, he has no idea what the new pattern is. It takes him forever to learn. So to eliminate that learning curve, you just take a picture of his panel that he's been working on for 20 years. You stick it on that HMI, and he follows that same pattern, and it works.
Okay.
Those are
That
things
makes
they
sense.
have to learn about converting from panel to there. And for people who have some ADA issues, they got to be able to see that stuff. So if they're having a problem, they need to know right away. So I just make my stuff compliant from the beginning. Not that we're trying to be ADA compliant or anything, but since we work with students and we know how bad they can be sometimes, you got to do the same thing there. It's got to be visual, not necessarily sound wise, because it's very noisy in most plants, but visually it has to be there, flashing stuff and things. So you're covering hearing impaired, and then verbiage has to pop up on the screen for your people who are deaf. So I mean, you got a lot of things you got to cover on those. So it's not just about building a simple screen to go. It's about how you build that screen. Second thing is they got to learn how to do multiple screens, because you want one for the operator, one for the supervisor that is coded. Nobody can get in but the supervisor. I mean, I'm talking like the production supervisor, so they can watch their shifts. And then you have one for the quality group, so nobody goes in and messes with their stuff but quality, and the technicians have access to everything. And then you have a maintenance screen. And what I make them do on the maintenance screen is set up some troubleshooting scenarios for lights, things that should be happening, values they need to be looking at. Are those numbers correct? So you heard me say in the ET meeting, it's not just about collecting data, it's about, is the data make sense? Is it accurate? Where are you getting this data from? My students are having to learn that the hard way because they're looking at calculations. Why is that coming out like that? I said, well, look at your maintenance screen. They'll go over and they didn't create one. I said, well, let's go create a maintenance screen. So when you multiply these two, what's the value? Show it on your screen. Make sure these values are coming out and then they find it right away. They find out where they made their mistake in their math, and then they go back and do it. And that's what we're going to do starting December. So what I want to do is I want to stop here. I want to start a new screen. Save this too. If you haven't saved it, just save it. What I did was I did door project FLATE, but you could do just door project. And this was the original one we did. But I just went ahead and recopied it there. And then I just save it back as that. And then what you can do is create a solutions manual a solutions folder for all these things. So you have them here and you can go back and look and see. Oops, I'm in program mode. So I'm going to tell you now.
Can you send, you did something last time. I don't know what you did. If you posted it in our chat, I can't remember, but you gave us that we had. Is there, I don't remember what you did. I think you did it in chat.
I did it in chat just a few minutes ago. I did it in chat a few minutes ago. If you go into the chat, you'll see it in there that I put in the original one right there that we started with.
Yeah, I had that one from last time.
Yeah, and then that's the one I did. If you want me to send mine, I'll send you mine too.
Yeah, of course I want your answers.
Oh my God. You got your own answer. You completed this.
No, I didn't. There's no way I could do both at the same time.
Yeah, we're too busy to do
I gave up. My current one has like 2 things in it, and then I quit.
All right, I just sent it to you. I sent it to you. The second one is completed. It has more kilobytes.
Thank you. I gotta play. The only way to learn this is just like when you teach this is they gotta spend hours playing with this. You can't watch.
This is why I Zoom every lecture I do, because I'm going over this stuff and I'm showing them how to do basic things. They go home and then they open that recording up and they go do it 20 times and they stop it until they get it done and then they continue. That's the way you have to do it that way. That's why Teresa's got us recording this, because we talked about this. She's got recordings out there. So you can watch it 20 times until you get it. That's the whole purpose behind this. All right. I opened a new one. It'll jump over what you had. You won't have a thing there. I want to change simulations to Silo Simulator. I know we're getting close to running out of time, but I'm going to go on as long as we need to, because we got to get this one. This is the second thing they need to understand. This is a whole different animal, guys. This is completely different from anything you've ever seen. So this is how I'm going to show you how I teach them. So I'm going to stop sharing for a second, and I'm going to share my whiteboard with you. And this is exactly what I do with them. So you see I have this beautiful whiteboard up here. And in the Silo project, you have a whole cabinet. So I guess maybe I should have done that first. All right, let me see. Let me do it one more time. Sorry, go back over. I wish I could split this on this one, but this one won't let me show you everything the way it's set up. I have access, but not complete, but I like this. I like this one. So let's talk about this one. How many outputs do I have on this one? Do you see how many outputs I have? Let's count them. How many do you see as far as outputs?
You got the first line 1, 2, 3, 4, 5.
I see 5.
5, right. Okay, good. How many inputs? Now there's 3 inputs here. Right. If I mouse over this, there's 1 point, because as you make a switch over, so there's 3 here. How many inputs do we have?
5.
How did you get 5? You got 1,
right,
2, 3.
3.
Yep.
All right.
4.
4.
0,
5.
1, 2, 3, 4.
Okay.
Right.
Well, here you got 3.
3.
4. 5, right?
Yes,
Yep.
Okay. And we said we had 3, 4, 5. Don't forget these.
Where are you at?
Those are 1 and 2, right? Start, stop.
Yeah.
so it's 7?
So I have 1, 2, 3, 4, 5, 6. No, I got 1, 2, 3, 4, 5, 6, 7. So are you saying you got 7 inputs?
Yes.
I think you have 12.
12?
Why? Where'd I get the other 5 inputs from? This is a question I ask the students all the time. Where are my other inputs?
It's a trick question, right?
No, it's a simple concept. It's just no trickiness. How many outputs did I have again? How many did we count? Was it 5?
Yeah, 5 outputs, 7
Yeah.
inputs so far.
I say you have 12. Where did I get the other 5 from?
Are you gonna tag something? Are you?
Remember, outputs can become,
Input. So it's gonna be one of the output, one of our other 5. Our 5 outputs are gonna become inputs. Yeah, it's not tagging, but literally.
you have 12 inputs you can play with.
Yeah.
That's what Sally already knows all this. She's here.
So you're saying the 7 we know, and then our 5 outputs make it 12 options. Okay.
Yeah, you got 12 inputs you
You're
can
right,
play
you're
with, right?
Yep.
So I have 12 inputs and I only have 5 outputs because inputs cannot become outputs.
Got it.
All right. So
The
think about that.
outputs can
That's the
become-
trick. That is the entire trick on this one. Okay. Now let me go back to the screen again because I want to show you exactly what I do with them on this one. This one's a little more complicated because they need to understand process. We're going to switch them over to how to do a process. So we're in a mode. So when I hit start, the conveyor should be running. So I'm going to come up here like this, right? This is process flow is what we need to be looking at. So I have an input here that's a start, right? I can't write on with a mouse. It's like writing with a brick. So here's my start. And I also have a stop, right? When I hit my start, what am I going to turn on?
The conveyor belt.
Everybody agree with that?
Yeah. Well,
I don't.
Let me
I
look. I gotta look at a
disagree.
picture.
I completely disagree with
Let
that.
me go look. Where's our process at?
What I do is when I hit the start stop, I put it in run mode. How do I know I'm in run mode on your diagram in there on your thing? What tells me I'm in run mode?
On that diagram?
No, on the software,
Yeah, I can't find the.
the panel.
Yeah, let me-
Okay, the LED.
All right,
Physical.
what's it called?
The run
What
light.
LED? Right. I'm in run mode. This is run mode. Then
Yeah.
that turns on my conveyor. Run is the input for the conveyor. Another input for that conveyor is my proc switch, right?
Okay. Yeah, yes, I finally have the picture. So I finally can help
Right.
you. Okay.
Proc switch is going to stop the conveyor.
Okay.
When that conveyor stops, I am now in fill mode.
Okay.
What indicates I'm in fill mode?
Well, let's see, I guess the solenoid output to one is,
Oh, no, look on your panel. You're looking at an operator. You can't see a solenoid out
oh,
here.
my bad, my bad. Okay, say it again.
How do I know I'm in fill mode?
Because it's lit up.
Right, fill light's lit up.
Sorry.
And my input to that one is my level sensor, right?
Yeah. Okay, gotcha. Yep.
Once I hit that, I'm now in what mode?
Once you hit what? The levels,
When the level's up,
you'll be full.
full mode.
Yep, full mode.
Once I'm full mode, I got to restart the conveyor.
Okay, yep.
This is the beginning part of it.
All right, gotcha.
I have three modes: run mode,
Yep.
fill mode, and full mode. So these two kind of run together because in run mode, I'm going to have my conveyor in there.
Got it.
So how am I going to program that? I'm going to drop this down right quick here.
Back to you.
And I'm going to share screen back to my Logix Pro. Now that you understand that little bit,
Okay.
how am I going to put it in run mode? I have a stop, a start. So I'm going to put a stop start circuit in here.
Yep, our classic stop
Start here.
Motor.
Click, click, click.
Yep.
Come on. This thing's not working too well
And
on
then-
my end. And then I'm going to drag this over here.
Yep.
This is a typical stop start.
Yep.
So here's my stop. I'm going to drag that up there, right?
Yep.
Right click on it, edit symbol, call it stop, right? Then I'm going to drag the start symbol over. Or the address, sorry. I mean, it's on the symbol, on the word. It's actually on the word, not the button. It's in this case. They weren't very consistent with that part of it. And now I'm going to go into run mode. So I'm going to use the run light.
Okay.
And I put PLT on mine, but the new wave is just LT for the new students. They don't know what P means because they don't use pilot, the word pilot anymore in a lot of this stuff. So I turn that on. I've got that locked on. In order to understand this and understand I am in run mode, I now teach them run comments.
Okay.
On your bit comments, you see I do a lot of abbreviation because you don't have a lot of space on those bits to write. 5,000 is a little better. But in a run comment, you can write a novel. So I could say hitting the stop button brings this process into run mode, and run mode will control the, all so. But for them, I said, make it simple until you get used to writing stuff. But this is where you explain how this rung works and the rungs below it if you need to. And everything after they do this project has to have run comments. If they don't, I dock them.
Okay.
Now that I have the run light on, I can start my conveyor. And that is this motor here. And I don't put motor because this is a conveyor motor. So I'm just going to write C&V for conveyor. I abbreviate on bits because you don't have a lot of space to write a lot on those. So in 500, you don't. 5,000 is a little better. I'm still in run mode. So what they want you to do is to run over here, stop under here, and then fill the box up and then move on, and just a continuous operation until you get there. Okay. This is something here on the thing here. So let me go back. I'm not trying to do anything weird. I'm just trying to get it back up. I lost my student exercises for some reason. So I'm going to get over here just to tell you what the first exercise is. The sequence can be stopped and restarted at any time using the panel mounted stop start switch. That's what we just did. Run will remain energized as long as the system is operating automatically. Run light, conveyor motor, and solenoid will de-energize whenever the system is halted via the stop switch. Fill light will be energized while the box is filling, and full light when the box is full, and will remain that way until the box has moved clear of the prox sensor. All right.
Where were you reading that from, Sam?
I pulled up the exercises. I can't show you both. Because of the
Okay,
way I'm set
but
up
I
in this.
should be able to access it, right? Exercises?
Yeah, if you go to help, go to student exercise, it'll open up a
Got
web
it.
page, and then just go down to the thing. Again, on this one here, I only give them exercise 3 is the only thing I want to see from them, because that's complete.
Okay. Got it.
All right. So now what I'm going to do is I'm just trying to get it to stop, fill, and roll again, and just start continuously filling boxes, okay? So right here, I've got the run light on. I'm going my conveyor. This conveyor is coming down until it hits what?
Our proxy sensor.
So as long as that prox sensor is not activated, that conveyor will work.
Got it.
How do I know that? Because I've done this a few times. But in the real world, they have to go out and see what type of sensor is this. Is it PNP or NPN? In other words, is it normally open or normally closed? We don't know till you get there. So this could be a different scenario. If it's a normally closed, then this would be on until a box hits it. And it just depends on the sensor and what they ordered or what the manufacturer brought in with you. That's why when I was a maintenance manager and plant engineer, I had my technicians work side by side with the folks coming in to look at how they program it, doing everything, because they need to know how the system works. And if you're not sure that this is correct, all you have to do is just, you don't even need to download, just put it in run mode. Notice the stop is on and prox is on. Do you see that?
Yeah.
All right. Now I'm going run light. It'll run until the prox is done. Now, what I'm going to say is when that prox is on, I'm going to do what Tim said. I am going to do what?
I can have that turn on.
You're gonna fail.
Have your solenoid output.
Fill, yeah. So I'm going to be solenoid valve is going to open up to fill it up. And I don't know why this popped up, probably because I dragged this down here. But now what's going to happen is I have got to add one more thing in here, and that is my run. If I'm not in run mode, this cannot work.
Okay, yeah.
So Sam and Tim, we're old school relay ladder logic guys. You remember we had the stop and then we had all these multiple lines down under the stop. We don't need to do that. We just put the run light now in front of everything.
Okay.
Makes it a lot simpler to
Yeah.
look at and
Yeah.
visualize when you do that.
Yeah.
So now
Right.
this one is now starting my what? Oh, sorry.
Bill.
Fill mode. I'm in fill mode now.
Right.
So looking at this right offhand, everything in run mode is in between these two in run mode. Everything between this and the full mode is going to be fill. So when I'm looking at this to troubleshoot and it's not starting, I just go to run mode and figure out what's going on. I only look at these two lines. That's all I need to look at. For troubleshooting purposes, this helps a little bit.
Mm-hmm.
Not a lot, but a little bit. And on December, we'll show you a much better way of doing this. So now it's done. The prox switch is on. I'm opening the valve. Not only is it locking out this, but it's also got this on until I'd hit what?
Until the level sensor.
Right. So as long as that level sensor is not on, and if I want to know what that is, I think it will mouse over and let you know. Yeah, it's normally open.
Okay.
Normally open.
Yep. That's what we assumed.
Right, right. I
That's
forgot you
nice
can
to
mouse over. It's been so long since I've moused over. Yeah. So now this is going to be the level sensor. So I just put LVL just for that. That's my fill mode. And then what I'm going to put down here is run light. And the other thing I could do is just loop this with the thing, right?
Yeah.
I want to make this a little more efficient, but when I'm working with students who are beginning to learn this stuff, I don't force them to put a loop underneath another output, although they can, okay? I just do it like this, and then I'll go, what am I doing here? Fill is going to be this, and it is going to be, where's my prox? There it is. Yeah, I probably should have done it that way, but it's all right. I'm still full. And I can put my run after this too, if I want to do it. I mean, you can do it any way you want to do it. Normally when I program, I'll drop a loop under here. So I'll make them do, they'll do it this way first, then I'll show them the other direction. Yeah. Delete that.
Cool.
And this will be the fill light. This is the simple way to do it. I almost put PLT. I'm so used to doing that for many years. It's hard to get off of it. So what I could have done is just made a loop under here, right? With this.
Okay.
Same thing, right?
Mm-hmm.
But sometimes they don't see that. And so they'll do it like this. And I'm okay with that. Then I'll come back and say, could we fix to make this a little easier, simpler? And then I'll show them, they go, oh yeah, I see it now. Okay. That's kind of thing that you're going to run into. Now then what we could do is we got that part done. Now when this other one comes on, we are going to, sorry, I was there. We're going to go ahead and do a level sensor working. And that is going to give me a full light. So this is now becomes what? Full. And you're saying, well, Sam, this is kind of redundant. I mean, why would you even do that? They can see it's full of it. Okay, yeah, all right. The mode is there not for the lights and all that. The mode is there to control the process. This is a process. We're in run mode right now. If I hit stop, nothing works. Nothing's going to move. Nothing's going to happen until I hit start. The run light controls the entire process. I have to be in run mode before I can do a full mode or anything else, right?
Mm-hmm.
So now I'm full. Now what do I do?
You want to go back to run.
I want to restart my conveyor, right? So I got to go back to the run mode and start playing on that one. So how am I going to do this? So it is, because right now my proc switch is blocked out. So what am I going to have to do?
Reset.
Well, I can, but this is already out because the box is sitting on it. I can't change that. So how do I get around that? When I'm full, I want to move off of that, right?
Yep.
Right.
How am I going to get around that? I said around it. So what would I use?
You're full.
What'd you say? Somebody got it.
No. Thinking out loud.
Yeah, go ahead.
No, because it's wrong. All right,
No,
so,
it may not be. It may not be. You said something that sounded right to me.
so we're full, right?
Yeah, so how do we get around that block proc sensor? Got to get around it, right?
So loop, yeah, across the input, across that input. There we go. Yeah, I see what you're doing
With what?
now. Our run light.
Not run. We're already in run. It would never shut off. We have the run light there.
Oh, okay. Our sensor. Wait a minute.
Which
That's
one?
the level.
Okay. Everybody agree with that?
Yeah, that'll work.
Okay. Everybody thinks that's going to work?
Well, maybe not. Let's see. Our level sensor now needs to. Yes, that is going to work.
All right. Let's put it in and
Is
see.
it? Oh, you're right. No, it's not. That's why you're setting this up.
We got to try this stuff. This is what your
Okay,
students
this is what I would
try.
do. Yeah, this is what you do. So I agree. This is what I'd be doing.
So there we go. You got that piece. So what do you think this is going to start off and go back running, right? You're about to hit the,
Yeah.
you're about to hit a point where you're going to have to figure out the trick to this one.
Okay,
Okay. So let's try this and see how this works.
let's see.
So what's going to happen is when I hit start, the run light's going to come on. This conveyor is going to stop here,
Yep.
fill up, and then move off, right?
Okay.
Kind of what we're looking for, right?
Okay.
Right.
Oh, so we got to shut the solenoid valve back.
What happened?
Yeah, we kept flowing. So we also have to address our solenoid output.
Oh, we got to turn it off. Yeah.
We just dripped everywhere. We did move it along. Hey, I moved it along.
Quick, turn it off.
So it messed up, didn't it?
Yeah, so okay, this is nice. See, that's exactly what the students need to see.
Yeah, no, I'm seriously,
Fantastic.
if they're gonna do this, they got to understand why they're having to do this. Okay,
Yeah.
so- well, yeah.
And it's like you said, this is good for their process. It's good for me to think about.
Well, and if they mark their rungs and label their rungs, they know between which rungs the problem is. So they're not looking at the whole doggone program. They're just going down to that area where that's happening and trying to figure out what's going on.
Yeah.
So
Yeah, I like the consequence there too, where it shut the plant down.
Yeah,
absolutely,
we
absolutely.
got to close the valve.
If you notice in the door, it'll do the same thing, and the motor will catch fire if they don't
Yeah.
Right.
interlock the motors and stuff or use their switches. That wakes them up a little bit.
All right, so now we got to figure out how you close the valve in this. So I want to add that.
Right. That's right. That's absolutely right. So we have how many inputs?
We have 12.
12.
Woo, got plenty to work with there.
Okay, yep.
So think about it. We come and oops, let me get back online here. We're coming and we're rolling down here and we stop.
Yep.
I've got to clear this proc sensor before I can go back to normal. I have to clear this. If I'm halfway between this and this, it stops and this valve opens and starts spilling product everywhere. This is real world. I'm going to tell you, they never line anything up in a plant. You know that.
Mm-hmm.
So the thing of it is how am I going to make that work? I got to get it past this point here. Well, if I use the level sensor, what's going to happen? As soon as it goes off, it's off, and I'm still on this, so that's not going to work. So how can I get past this?
We got to link the level sensors results to that.
We already have. We got it right here.
Okay.
We have 12 inputs. Remember.
Okay, so I gotta use another one. Let me see. What else?
So right now, when I'm all the way to the top here, what am I?
You're full.
Right.
So we're gonna use that. We're gonna use the full output to trigger.
Oh, the full light. Look, listen to that. Oh my gosh.
Good.
Woo.
Of
All right.
course, of
So
course.
what we got to do is just like anything else, got to lock it on.
Yeah. Got it. It's making sense. I still don't know how I can't wrap. I gotta, like you said, watch them.
It's practice is all it is. You
Yeah.
haven't had enough of this PLC logic. You had
Make it-
tunnel relay. I imagine you could wire this blindfolded relay wise, but PLC is a whole nother world, man. I'm telling you, it's hardest thing for me to switch over. But you'll get there. You will get
Now,
there.
you said, Sam, I can get these videos literally because that's what I need to do is I get through it and watch and think and see. And so we have access to these videos you produce.
Yeah, yeah. You mean the ones I do in class?
Yeah, right now, what we're doing in these past few.
No. Teresa's recording them. They're out there on the FLATE website. Yeah.
Perfect.
They got that professional development area there where you can go in there and look at these. Ernie keeps all of it from everything we've ever done. I go back and watch some of Ron's old stuff and things. He had some cool stuff going on. I kind
I
of
don't
look
take
at his.
advantage of it. I need to.
Yeah. That's why, I mean, Ernie lets us do this, lets us record for future. If anybody wants to go out and go through this stuff, through this basic part,
Perfect.
then you guys are going to do the rest of the exercises and see if you can figure it out. When we come back in December, we'll talk a little more about it and then we'll go move forward from there.
Okay.
All right. So right now you've got the full light on. So that'll probably get us past this point, but it's going to be on
Okay.
for how long? Forever.
Um,
You're going to be bypassing, right? Because it's always on. So when do we have to cut it off? So we want the full
When it
light on
fills.
as long as what's on.
our conveyor.
Now, you want the full light on
Until we do what?
until you fill it.
Well, no, when we're full,
Yeah.
the full light comes on, which moves the conveyor. You want to get past what?
The proxy set, the input sensor.
Right. So as long as that prox sensor is engaged,
Yep. So
we want that full light on. And then this needs to be not the level sensor, but
this O2, the solenoid.
the full light.
Oh, wait a minute. Pardon me. Yes, the full light. Yes. I see where you're at now.
Right. Also,
I see where you're at.
this can only open if what?
Say that again.
I can only open the solenoid if what? The full light
If
is
the
not on.
prox,
If
the proxy light
full light
is on.
has to be on before the solenoid changes.
Or because once I pass this and I'm on this, it's
Yep.
going to try to fire up again. So I got to keep it past that point there. So do I really need this now?
No.
Not really,
Right. He's correct.
Hmm.
That's a good point.
because the full light's going to take care of that.
Yep.
There you go. Almost the same thing here.
Yep.
Okay.
They got this. I mean, this is correct the way they had it. But now that I got something else to control it, I can use that to control all this.
Okay.
That is the trick to this program.
Okay.
Outputs can become inputs. They have to learn that concept at some point. And this sends it home because just using the sensors is not going to help you. Let's run it now and see if something doesn't work. I think we got everything, but I don't remember what all we had to do. Ah, missed it. I'm gonna slow it down a little bit so I can hit it right when it goes past the, see if it does. So you need to test their circuit like I'm about to do.
Okay.
I am still on this, I think. Man, maybe not. Okay, so I gotta be quicker. My fingers aren't fast enough. It's old men. Okay, this is on, this is off. Nothing spilling. You can see right here, my prox is on. My level sensor is not on. I'm in between.
Yep.
Nothing spilling because I've got the full light controlling it.
Got it. Wow. That's clever.
Not clever, it's just logic. Don't confuse intelligence with proper
You're
use of logic. Yeah.
right. That's logic.
Now, I'm going to tell you, your students are going to do it 3 or 4 different ways and make it work. As long as it works, it's good. So I test these things, and then every one that I got, I test this exactly like this. I make sure I stop it between so it's not spilling anywhere. If it spills at any point in time, it's no good. I give them a 0 and say, go try it again. You're still spilling product. I make them work on it until they get it. Once they get this concept down, this can be used anywhere. Outputs can become inputs. That's why your B3s can also become an input up top. Remember on the last one? Those were outputs. We made them inputs. So your lights can be used. So I don't have to wire another doggone relay, and I could just use the output as an input. That's not, how many lights do you know have contacts on? That's the beauty of the PLC.
Yeah.
You can make it like that.
Amazing. That's yeah. That's mine. That's like, it's amazing to me. That's interesting.
Yeah, you'd have to wire a parallel relay with that, so it comes on when the light comes on. If we were doing relay ladder, you don't have to do that with a PLC. That eliminates all of that. That's why GM moved to this as quickly as they could when this first come out in the 60s. And they were all over it because they said, man, it's going to save us tons of downtime. Third industrial revolution. All right. You see how that is?
Yes.
Too easy
I'm
almost.
going to read the next scenario to you because we're going to stop here. You should have this. And actually, I will put it up in the link right quick here. I'm going to save this and I'll put in the link while I explain what you got to do next. I'm going to show you the rest of it here. Let me see if I can save this. Hold on a second. This is the silo FLATE. Oh, can't spell. Hang on a second. I'm going to put it up in the chat for you guys, so you guys have it in the chat so you can download it. Okay, I think I got this. Okay, y'all should be able to see it now, I think. So you have a copy of this one. I'm gonna
Yeah.
shut this down. I'm not gonna need this anymore because we're just gonna discuss what's going on with the rest of the scenario. I want you guys to work on while we're gone till December. I think that's not it. Is that it? Yeah. Oh, that's a silo one. Sorry, I grabbed the wrong one. My bad. It is the one for the, no, that's silo. That was right. Silo. Sorry. Can you guys see the silo one now? I don't know if
That's under help, right? Yes. Okay.
Okay. Yeah.
Yeah.
This is what you do when you're under the help.
Yeah.
You go there, it opens a web page, and then
Yep.
I just, and they're all there if I go back one, but here's the first one you just did. That was just the first exercise.
Okay.
Second exercise, rewrite or alter, which I make mine alter. Stop the conveyor when the edge of the box hits the prox sensor. That's what we're doing now, right? When the box is in position and the conveyor stopped, open the solenoid valve, fill the box until it's full. Fill light, full light. Once the box is full, it does not take off. Now you momentarily press the start switch and move the box off the conveyor into a new position. To a new box comes into position. So what you're going to do is you're going to stop under the conveyor. It's going to fill, and then everything's going to stop. then you're going to hit the start again and it's going to take off and go. Okay. That's where those switches A, B, and C come into play. You understand?
Yes.
Read the next one. A position is continuous mode, which is what we did. B position is manual restart mode. So on your conveyor, that first line we just went through and did all that stuff, that's your A switch. Now you got to loop that with a B switch. And what happens on B? And then I got C where I just keep going. I don't stop or do anything. And you got to look at all your lines and make sure you're bypassing every operation in the C mode. So only certain operations will happen in certain modes. See what I'm saying?
Yes.
I won't stop. I won't fill. I won't do anything if I'm bypassing. If I'm in B, it has to stop. And then I got to hit start again to get it re-going.
Okay.
A is automatic. It just does what we just did. See if you guys can play with that.
Okay.
Right.
That's all you got to do. That's the last thing I just have them turn this in. When I flip to A, it better be running continuous. When I flip to B, it better stop. When I hit the start, it goes. And then when I flip it to C, everything just bypasses. If that doesn't happen in my thing, I tell them you didn't do it right. You go back and redo this. Your A or your B or your C is not working properly. And I said,
so we're responsible for just turning in exercise 3, right?
The last exercise on every one. You don't have time to grade 3 exercises for each one of these or 4.
Right. Okay.
You just do the very last one and you watch it operate. If it works, it's done. If it doesn't work like it says it's supposed to, you give them 0 until they fix it. And then if they do fix it, I'll move their grade up to 100. I don't dock them for that because they don't know how to program. They're still learning. This is all basic. This is the first level class. This is basic stuff. I get them until they're successful, but you got to fail before you can be successful, right?
Sure. Absolutely.
That all the time. You know, how many times has Trump been bankrupt, but he's a billionaire? Same with Ted Turner, same with, you know, Bloomberg and all of them. They had a lot of failures before they had that one success. So in the beginning classes, I make them fail. I force them to fail. I want them to fail. That's how you learn. How did you learn that stove was hot? You had to, one time when you were young, put your hand on that stove so you know not to do that again, right?
Or electricity shocks, right?
Absolutely. Although I think I must have been stupid on that one because I still get
Yeah, I'm still getting shocked.
Yeah, we may not be as smart as we think, but yeah. But I'm just saying, you know, that's the kind of thing they have to learn some of this stuff the hard way. And the last thing I'm going to tell you before I walk out of here, don't beat your students up too bad because, you know, if they happen to blow up an HMI because they didn't wire it properly and all that, you dock them for that. I mean, I penalize them. They're gonna lose, but I'm not going to throw them out of the class or not pass the class. I'm going to sit down and have a long talk with them. What did you do wrong? Tell me what you did wrong. And they're shocked. He goes, how much does that cost? That's a $2,000 HMI, man. They're thinking they're going to pay for it. And I'll let them think about it right up to the last minute because they are so upset at that point that they're just like, I don't know how I'm going to do this. You know, and then I tell them, okay, this is a lesson learned. I'll cover it this time. Cannot happen again. You need to be looking every time you wire something. You better know what the power is on it. It's a dangerous situation you put yourself in and the rest of the community. And you got to really, really get them on board. And then, you know, they might get a 0 for that one assignment, but they're not going to fail the class because they did do some good work. But I guarantee you, they will never make that mistake again.
Okay.
I've yet to have a student make that same mistake twice. I've only had a couple of them blow something up like that. But those guys turned out to be the top techs wherever they went. Because you got to make those mistakes in order to learn. It's all about learning. That's what I'll leave you with. Any other questions, answers, smart remarks, anything I can do for you guys before we leave?
I appreciate it, Sam.
Thank
No
you,
problem.
Sam.
Anything else?
Hey, nice job.